Okay, so in this lesson, we're going to be writing equations for these transform functions. In this case, though, you're given the order in which things occur. So you're told words. And remember, in the previous lesson, you were given the specific function, and you were asked to come up with the description. So here you're told the description, and you have to come up with your equation. All right, so make sure if you need to, you go back and review the lessons that dealt with these ideas. So in previous lessons, and there were several that focused on these, we talked about vertical translations, we talked about horizontal translations, we talked about reflections, whether it's over the x-axis or the y-axis. We talked about stretch and compression, whether it's vertical or horizontal. And as we talked about that, we looked at what the notation looks like, and we also talked about what the points look like. Okay, so just go back if you need to and review these lessons that dealt with this. But in these problems, in this lesson today, what we're going to do though is kind of summarize all of this with these problems. Okay, now as we go through this, and then if you do the same thing I'm doing, is this. So notice that for example, number one, you're given your basic function, your parent function, and you're told that the first thing you're going to do is you're going to write it upside down, so to speak. So remember, that's a reflection about the x-axis. Then the next thing you're going to do is shift it to the left 9 units. So what I want you to understand here is that as you go through these, you need to look at your transformations and how many there are. So there are 2 transformations here. So what I want you to do is this. So here's your first one. Now make sure you do it in the order in which you see it. Okay? So the order in which you see it. When the descriptions are given, it's got to be in the order in which you see it. If the symbolic representation is given, like in the previous lessons we did, so remember there was a lesson where the symbolic one was given, the symbolic function, you're asked to write the description of the transformations and then graph each one. We looked at 2 parts. So we did some problems in part 1 and we did problems in part 2. That, remember, you had to use a specific order that was this. All right, so first thing you would do is do the horizontal translation, then you would stretch or shrink, then you would reflect, then you would do the vertical translation. Okay, so that's what you do when the symbolic representation is given. But here, you're given the verb one, so it's got to be the order that you see it. Okay? All right, so this is going to be my first one. So what I want you to do is say this. You're going to say y1 then, so that the y sub 1, the 1 means my first transformation. So what I'm going to do is I'm going to take x squared, my parent function, and I'm going to reflect it. So upside down means reflect about the x-axis. So instead of pointing up, it's going to point down. Okay? So that's where you have that negative in front. So that'll be a negative x squared. So make sure as you go through this, you make notes. If you still don't remember some things, just make notes. But at this point, based on all the lessons we've done, this should pretty much, for the most part, you should know all this by now. Okay? So notice that the reflection of the x-axis where you have a negative out in front. And that's what this is. Okay? Then we're going to shift it to the left 9 units. Now remember, with all the lessons we've done, that's the one, the horizontal shifting and horizontal stretching or shrinking, that's the one that causes students the most difficulty. So this one here, this right here, the horizontal translation, these two, and the horizontal compression and stretch, those two, that's the one that causes the most issues. So when you get to those, just be very careful. Think carefully when doing these. So the thing you got to remember though is that when you shift to the left 9 units, you got to think counterintuitive. So instead, so that's my second transformation. So instead, So what I'm going to do now is I'm going to shift this to the left 9 units. So instead of saying x, because intuitively you would think x to the left, you're going to the left of 0, the origin. So you think negative, right? But no, you got to think counterintuitive. So this is going to be x plus 9 squared. All right. So first thing I did was I reflected it, and then I'm shifting it to the left 9 units. Okay. All right. So your answer then, you can write this as in function notation. You can even say y equals. All right. It didn't matter. So you could say y equals this right here. So negative in parentheses x plus 9 squared, or you could use function notation, say g of x. It doesn't matter whether you say g of x, h of x, k of x, does not matter. Negative x plus 9 squared. Okay, so either one of those is fine. That's your answer. Okay, number 2, this time your parent function is the absolute value function, and this time you're reflecting about the x-axis. So instead of using the word upside down, they actually used the correct terminology. Mathematical terms, so it's about the x-axis. So that's where you have that negative in front. So that's going to be my first transformation right here. So you're going to say y1 equals negative absolute value of x. Okay. Then the next thing I'm going to do is I'm going to shift it to the right 4 units. So that's your horizontal. Shift right, left, that's horizontal. That's the one you got to be careful with. So whenever you hear that horizontal translation, or horizontal stretch or shrink, be careful. Okay, so I'm going to do to this one, to this graph, I'm going to shift it now to the right 4 units. So that's going to become, the second transformation will be negative, and then remember to the right, so it'll be x. This one right here was to the left. This one was to the left. This one's to the right. So it'll be x minus 4. Okay, x minus 4. Then my third transformation is where I take this and I shift it down 3 units. Now, so the vertical, remember that's a vertical translation. So those are easy. It's intuitive what you think. So if I go down, I'm going to say minus 3, right? Okay, so that'll be your third one. Third one will be negative x minus 4, absolute value of that, and then minus 3. And so there's your answers. Your answer, you're going to say either y equals, or you can say f of x, function notation, and that'll be your answer. All right, but don't just say, don't just give this. You got to have a function notation involved. You got to have an equation. So you got to say y equals or some function notation, but just don't put this as your answer. Okay. All right. Number 3. So this time you have the cube root function. So that's your basic function, and you're shifting it 4.8 units to the left. So that's your horizontal. Okay, so you got to be careful with horizontal. So my first transformation says I'm going to shift this graph 4.8 units to the left. So it's going to be the cube root of x plus 4.8. Okay, x plus. So to the left, you think counterintuitive. Then it says I'm going to stretch vertically by a factor of 6.3. Okay, that's an easy one too. I can do that. So that's where you multiply it in front. Remember the stretching, the vertical stretch or the vertical compression. That's where you multiply that factor. So the a here is your factor. Okay. So then you're going to have 6.3 times the cube root of x plus 4.8. And then you're going to reflect it about the x-axis. You're going to reflect about the x-axis. So that's where you put that negative in front. So my third transformation. So this I had 3 transformations. First, second, third. And make sure you say y1, y2, y3. Don't just say y, because then you're indicating they're all the same thing, and they're not. All right, so then you're going to say negative 6.3 times the cube root of x plus 4.8. Okay? All right, number 4a. So 4 says write the equation of the graph after the indicated transformation. So it's same thing as what this is saying, except this says uses the word characteristics, and this just says after the given transformation. So it means the same things, just depending on your textbook or where the questions are coming from, they may use different words, but means the same thing. So here you're given your cube function, your cube function, and you want to shift it 4 units to the right. Okay, it's horizontal. So remember, you got to be careful. Horizontal. All right, so my first transformation is where I'm going to shift it to the right 4 units. So that's going to be in parentheses, x to the right now, so it'll be minus 4 cubed. Don't forget cube. So that's my first transformation. Then I'm going to stretch it vertically by a factor of 5. That's an easy one. So when you stretch vertically, that's easy. The only two ones you have to be careful with is your horizontal translation or your horizontal stretch shrink. And so stretch vertically, I'm just going to take this, multiply by 5, and then I'm done. I'm done with that one. So it'll be 5 times x minus 4 cubed. So that'll be your answer. So your answer here is f of x equal 5 times x minus 4 cubed. And over here, your answer, I didn't write, I forgot to, but your answer here will be something like g of x equal this right here. So negative 6.3 times the cube root of x plus 4.8. Now don't forget to extend this. You see how I have it? So some of you may do that. It looks like the only thing you're taking the cube root of is x. So make sure, remember it's the whole thing. So make sure you extend it. Okay? The whole thing has to be under the square root. All right. B. So you have the graph of y equals square root of x. That's your parent function. And the first thing you want to do is you want to shift it 6 units to the left. Okay, so here's another horizontal translation. So you got to be careful. So my first transformation is I'm going to take this. I'm going to shift it 6 units to the left. So it'll be x plus 6. Okay. Then my second transformation, I'm going to take this now. I'm going to shift it up 4 units. Okay, that's easy. So that's a vertical translation. So my second transformation is I'm going to take this and I'm going to shift it up. And so there's your answer. If you don't have any other transformations, that's your last one. So there's your answer. So the answer, you're going to say f of x equal the square root of x plus 6 plus 4. Okay? All right, let's look at the next one. So in number 5, you want to write a function whose graph is the cube function, and it is horizontally stretched by factor 7. All right, so you only have one transformation to do, and it's a hard one. So remember, whenever you have the horizontal translation or a horizontal stretch or compression, those are the two you have to be careful with. But whenever you have horizontal stretch or horizontal shrink, that's a hard one. That is a hard one for students. So let's kind of review something we learned about horizontal stretch or shrink. Okay? So remember, whenever you're dealing with horizontal stretch or shrink, so this is a review for that one. That may help you with coming up with the answer. Horizontal stretch or shrink. That is where we have this situation, y equals f of c times x. So if you go back to your lessons, we use c. This right here, they use b as your letter. But remember, we use c, but it's the same thing. So when we did this though, so remember our discussion. We need to go back and review that lesson. But when we did this, we said this. We stretch stretch horizontally. Okay, so we stretch horizontally by a factor of, now this is where you have to be careful. If you go back to our lesson, when we said a factor of, we said we take the reciprocal of c, and that's our factor. All right, so we don't say factor of c, okay? We say a factor of the reciprocal of c. So that's where students get a little troubled with horizontal stretch or shrink. It's this idea of factor. And when we talked about this, the reason why it's factors, because when you think of factor, you think of product, right? When you think of factor, you think of product. Factor, you think of product. So remember when you factored polynomials, you wrote them as multiplication, you wrote them as products, okay? So when we did the points, so remember when we do horizontal stretch or shrink, whether we go to the right or to the left, horizontal stretch or shrink, that's where when we did our points, we divided by the x coordinate by c. So remember the y coordinates stay the same. The x coordinate, they differ by this this factor where we divided by c. In this case, it used b, but we use c. So what I want you to understand is that this became x divided by c comma y. And what I want you to understand is that if I look at x divided by c, that can be written as x times 1 over c. And so this is your factor. That's your factor. That's what you're multiplying x by, is 1 over c. Okay, so what I need you to understand is this now. Whenever you say you stretch horizontally by a factor of, that number is not c, that number is the reciprocal of c. So that number that goes there is the reciprocal of c. Reciprocal of c. Okay? All right, so that's going to be important. That is a very difficult one to get. But remember, when you talk about stretch horizontally or shrink horizontally, stretch or shrink horizontally by a factor of, that is not c. That is not what you're multiplying x by. That's the reciprocal of c. Okay? All right. So let's go to number 5. You want to write a function whose graph is y equal x cubed, but is horizontally stretched by a factor of 7. Okay? So if you say this, now let's think about it. Write something down that you think it may be. So you may think, well, think, is it this? Is it y1 equal? Remember, you're stretching horizontal. You're stretching horizontally, so that's where it goes on the inside. See right here on the inside. So, and that was x cubed. Yep. So is it this? Is it 7x to the third power? So remember, this is c, right? So if this is c, right here, if that's c, are you going to say I'm stretching by a factor of 7? Or are you stretching a factor of 1 over 7? What is it? Okay? So when you're, remember, you're, let me go back to this. Okay, so if you wrote this and listen carefully, then you're saying c is 7, right? Okay, so when we say c is 7, what you're doing is you're saying x divided by 7. X divided by 7. So that means xy would become x divided by 7 comma y, whatever y is. But here's the thing though, you gotta remember x divided by 7 means x times 1 over 7. So that would mean that this right here, you're stretching by a factor of 1 over 7. But that's not what this says. So your factor is 1 over 7 if c is 7. So remember, you take the reciprocal. But you want your factor to be 7. So that means that it cannot be 7 here. So that cannot be right. So that means that y1 is 1/7 x cubed. Because if I take the reciprocal 1 over 7, then what's that? It is 7, and that's what that says. So remember, when you say stretch horizontally or shrink horizontally by a factor of, then this right here is the reciprocal of c. Okay? So if I want my factor to be 7, if I want my factor to be 7, if I want my factor to be 7, then what that means is that, if I want my factor to be 7, then what that means is that, so if I want my factor to be 7, then this means that C equals the reciprocal of this. So it'll be 1 over 7. So that's C. Okay? So that means that y1's this. So because that's C. So if C is 1 over 7, then that means that I am stretching horizontally by a factor of 7. Okay? All right. So if you go back to this handout right here, so remember, if C or B, whatever you're using, C in this case or B in this case is 1 over 7, and that's between 0 and 1, right? So you're dealing with a horizontal stretch. So you need to be careful. Don't say that you're stretching by a factor of 1 over 7. That's not what this means. Okay, this is C. Okay, so the factor is the reciprocal of this. That's your factor, and so that came from our discussion here, how we rewrote this division as a product. Okay, so it is a little bit harder to understand, but the answer is this right here. So in number, there's only one transformation, and your first transformation was to stretch horizontally by a factor of 7, so that means that C is the reciprocal. So C is the reciprocal of 7, which means C equals 1 divided by 7. Okay? So we're going to get 1 divided by 7 x cubed. So that's the answer. All right, so that one was hard, so just make a note of that. That was a difficult one. This is difficult to understand. Okay, so let's look at number 6. So number 6 is you want to write an equation that results in the desired transformation. So you have x cubed, and this time it's vertically compressed. So the vertical is easy. That's the number on the outside. And so you're shrinking it. So you're going to have your only transformation is 0.7 x cubed. And so your answer, you could say y equals 0.7 x cubed, or you can write it in function notation, f of x equals 0.7 x cubed. Same thing here. I just didn't put it in function notation. You could say g of x equal 1/7 x cubed. Okay? Now be careful. Remember, the 1/7 times x is inside that parentheses, and that's being cubed. All right. Number 7. Number 7, you have 3 transformations going on here. So it says, find the function that is finally graphed after the transformation are applied in the order listed. First thing you want to do is vertically stretch by a factor of 5. So that's the easy one. So the first thing, so y1 will equal 5 square root of x. Then the next thing you want to do is take this now, and you're going to shift it down 3 units. So you're going to shift it down 3 units. All right, so y2 will be 5 square root of x, and then you're taking this and shifting it down 3 units. Then you're going to take this and you're going to shift this whole thing to the left, to the right 4 units. So y3 will be 5 square root of x, and we're going to the right, so we x minus 4 and then minus 3. All right, so that'll be your final answer. So f of x will equal 5 square root of x minus 4 minus 3. Okay? Number 8, you want to find the function that is finally graphed after the transformations are applied to the square root function. All right, so our first transformation is that we're going to shift it up 5 units. So y1 equals the square root of x plus 5. Okay? Then we're going to reflect that about the y-axis. Okay, so we reflect that about the y-axis. So remember, when we reflect about the y-axis, that's where you have that negative in front here. Okay, so y2 will equal the square root of -x and then plus 5. Okay, so that's where I'm at. All right, so remember the reflecting about the y-axis is if the negative's on the outside right here, that's the reflection about the x-axis. The negative's on you're reflecting about the y-axis, so it's the x that's negative. All right, so just remember you may need to go back and just kind of review your reflections. Okay, so then what you want to do next is you want to shift it to the left 7 units. So this is the one also where you have to be very careful. Remember, the horizontal translation is where you have to be careful. Okay, now we are doing the horizontal translation last year because that's the order they told us to. You got to be careful. The answer is not, so Y3 is not this, and that's where students are going to mess up. So they're going to think, okay, so the next thing I'm going to do is I'm going to shift it to the left 7 units, and they're going to write negative x plus 7, and then plus 5. They can say that's the answer. It is not. That is not the answer. Okay, that's not the answer. If you recall, if you think about it, if you were to take this right here and you were to graph it using our transformations, using the proper order when the symbolic one is given. So if your function is written symbolically and you want to describe the transformations, you have to do it in this order. Okay? So I want you to think about this. If we do that, if we do this, the first thing we're going to do is we're going to take the square root of x and shift it to the shift it to the left. So the first thing we're going to do is shift it to the left 7 units, right? Okay? So then you're going to reflect, and then you're going to add 5. That graph, if you were to do this, that graph is totally different than the order that's listed here. All right, so watch what happens. Let's actually do this. Let's take the time and actually graph this, and you're going to see what I'm talking about. Okay, so watch. Okay, so what I want to do is kind of show you that what we're doing here, now this is not the final answer, because there are 3 transformations, this is only 2. But the order, this order is different than this order. The graphs are different. Watch. Okay, so let's do this order first. Okay, so what that says is this. So what that says is I take the square root function. All right, so remember your basic function. Remember what we did. So we have 0, 0, we have 1, 1, we have 4, 2, and we have 9, 3. Okay. So that's the graph of the square root of x. So y1 equals square root of x. Okay. Then it says you want to shift it up 5 units. Okay. So remember what that did. So it took all these points and shifted it up 5 units. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's my second transformation. So this is y2. So y2 then is square root of x plus 5. And that's where we act, right? Well, right here. Okay? So then the third thing I want to do is I want to take this and reflect it about the y-axis. So 5, 0 stays 5, 0. When I reflect this point about the y-axis, I get this point, right? So 1, 2 becomes negative 1, 2. Remember, the x-coordinates change, become opposites. The y stays the same. So whenever you reflect about the y-axis, the y-coordinate stays the same. The x are opposites. So this point here, that's 4, 7, becomes 4, negative 4, 7. So negative 4, 7. Okay, and then the point here that was 9, 8 becomes negative 9, 8. So negative 9, 8 is right here. So you get this now. Okay, that's what you get. So that's what this is. So y2. So y2, well, okay, this is y1 because that's what we said. So y1 was this, and this is y2. So y2 is the square root of negative x plus 5. Okay? Now here's where we at next. So now it says finally shift that 7 units to the left. Okay, so I'm taking all these points now. So the red's giving me my final graph. So I'm taking this, I'm shifting it 7 units to the left. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I don't have enough room to do this one. But basically, this is what your final graph looks like. Okay? So that would be my final graph. So that's going to be y3. All right? And that's what they're trying to come up with. What is that answer? You know, what is that equation? That's where we're at. Some of you are going to do this, because it said shift to the left 7 units, and just like we did, naturally so, like we did, if it says to the left, then you say plus. Okay, no big deal. That's what we said. Now let's actually graph this like we did in the previous lesson. Okay, so let's see if we get the same graph. All right, so first we're going to do is whenever the symbolic representation is given, we have to use our order. Okay, and remember, our order is, first thing we do is your horizontal translation. So according to this right here, I'm going to, first of all, let me go ahead and graph the square root function. So do 2 and then 9, 3. So there's our square root function. So y equals square root of x. Okay, so my first transformation says I am going to shift it to the left 7 units. Okay, that's what it says. All right, so let's go ahead and do that. Shift to the left 7 units. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that's what the second one is. Y'all agree? All right. So then it says now, remember now I'm going to do the reflection about the y-axis. The reflection about the y-axis now. Okay, so that means that every point reflected about the y-axis. So negative 7, 0 becomes 7, 0. Negative 6, 1 becomes 6, 1. See this? Negative 3, 2 becomes positive 3, 2. And then 2, 3 becomes negative 2, 3. And so I get this. Okay? Then we always do the vertical translation last. So then this says I take what I just did and move it up 5 units. And that's going to be the final graph of that one. So if I move it up 5 units, I get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Maybe I need to find that point just here, right here. 1, 2, 3, 4, 5. And then finally this one. 1, 2, 3, 4, 5. Oops, I missed it. 1, 2, 3, 4, 5. So our question to you is this now. So this right here is this. So that is y equal the square root of negative x plus 7 plus 5. Is that the same as the problem you're interested in? No. So you see, if you write it like this, it's not correct. So let's think about what to do next. How do I get the correct answer if it's not that then? Okay, so here's the problem. Okay, so remember our order. Our order was always whenever a symbolic one's given, was always a horizontal translation first. So that means when I did this, x was not negative already. The coefficient of x was 1. Okay? What happened now is that the order in which they told you the reflection first, right? In your order, the reflection is not listed first, the reflection is listed third. So that changes things whenever you're told an order that's different than this. So what you got to do is this. So you got to carefully listen to what I'm saying. So So this is not x, it's a negative x. So what that means is this. What that means is this. I am going to cover up that negative symbol right here for right now. I cover up that negative symbol. So I rewrote it, I'm covered up. And if I'm going to shift it, if I'm going to shift this graph here 7 units to the left, then I'm going to have inside my parentheses, I'm going to have something that says x plus 7. Okay? Because the plus 7 says to the left 7 units. Then I have a negative out in front. And then the plus 5. Now if I distribute that negative, notice what happens. Y4 equals, well, it's still Y3. Y3 equals the square root of, if I distribute, I get negative x minus 7 plus 5. So you see, those are different. Those are different. This right here is actually this. And that's what you wanted. So let's see if it's true. Okay, so remember, let's remember this is what I want, right? This is what I'm saying it is. All right, let's look at the order. Okay, so listen carefully to this. According to our rule, whenever a symbolic representation is given, I have to do horizontal translation first. So let's do that. So according to this, I'm going to take the square root of x, I'm going to shift it to the right 7 units, right? Okay, so I'm going to shift it to the right 7 units. So let's go ahead and do that. And watch what happens. Watch what happens when I do that. Okay, so when I take the square root of x, and I shift it to the right 7 units, I get this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I don't have enough room, so I'm just going to leave it like this for right now. Okay? Then I'm going to reflect it about the y-axis. So I'm going to reflect about the y-axis. So 7, 0 becomes negative 7, 0. 8, 1 becomes negative 8, 1. And this was 11, 11, 2 becomes negative 11, 2. So right here. And so I get this. Okay? And then finally, I'm going to shift this up 5 units. So I'm going to go up 5 units. And notice what happens. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's the graph I get. Now remember, this order gave me this graph, right? Is this the same graph as this one? Yes, it is. That's the same graph. That's what I wanted. So therefore, this right here is my equation. Okay? So this order though, now be careful. I want you to think. This order here is this series right here. So I had to do to the square root function. I did this transformation, then I reflected, and then I shifted horizontally. Okay, that's using the ones in the order in which you were told to do. All you want is to come up with this equation. So the equation turns out to be this, which if we graph it according to our rules, we get the same end result. Okay? So there's our answer. So what I need you to do is this. So the issue is whenever you shift horizontally, you have to be dealing with x, not a negative x. You have to be dealing with x, not a negative x. So you need to cover up that x, cover up the x, and in parentheses say x to the left 7. So you say x plus 7, and then put the negative out there, and then distribute, and then that's your answer. So that one was a hard one. So that one was difficult to do. The mistake you're going to make is this one. All right, that's going to be your mistake. So what I would do is, and you may have time to do this, do what I did. Do what I did. So I said, well, I don't know if this is right. Is this right? Is this going to give me the graph I want? And so if you do this order the way you're supposed to from our previous lesson, you're going to see that you get this graph instead. That's the one you get. And that is not the one you want. You want this graph. Okay? So just do that. So if you write something down, go ahead and graph it and see if it's the one you want. Okay? All right, so that one was a hard one. Let's look at the next one. So number 9. Okay, so number 9 says, write an equation that results in indicated transformation. So you have a squaring function, and all you're doing is shifting down 6 units. Now, all the purpose of this problem is to see if you know what the squaring function is, what that means. So remember, the squaring function is x squared. All right, so your answer is going to be, now it says write an equation, so you got to have an equal sign with y, or f of x. So your answer is going to be y equal. So you're taking your squaring function, you're shifting it down 6 units. So the answer is x squared minus 6. Okay, so that all they want you to realize was what do you know what the squaring function is? Do you know what the absolute value function is? All right, so let's talk about that. So you have the absolute value function, and you're vertically compressing it by a factor of 1/5. Okay, and then you're reflecting it about the x-axis. All right, so what do you think the answer is going to be? So you're going to have y equal. You have the absolute value function, right? You have the absolute value function. You're vertically compressing, so that's an easy one. Vertical compression, vertical stretching, that's where the factors on the outside. So you're going to say 1/5 of that. And then you're going to reflect it about the x-axis. That's an easy one as well. So that's this. Okay? Then you have a cubing function. So that's x cubed. So you're going to say y equal. So before we write anything, let's just see if there's a horizontal translation. So you're vertically stretching, that's an easy one. And then you're reflecting about the y-axis, that's an easy one as well. Okay, so listen carefully about to say though. All right, so you have a cubing function. So you're going to say this. You're going to say, all right, I'm vertically stretching by a factor of 4. Okay, so I'm going to have 4 in front. Let me do the first transformation. Let's do each one separately. The first transformation is I'm going to have 4x cubed. Okay, I agree with that. Then let's do the reflection. So the reflection, then you're going to say this. I'm going to take this, and if I'm going to have a reflection, then that means that x has to be negative. All right, just like that. And that's true. That is true. So if you want to, you can say your answer. You can say your answer. No big deal with this. You can say your answer is y equal 4 times negative x in parentheses cubed. But that is probably not the answer you will see, though. Because you got to remember this. Look at that negative x cubed for a moment. Negative x cubed means negative x times negative x times negative x, right? And that's a negative x cubed, like that. So what that means is that this right here, I'm going to go ahead and rewrite it. What that means is that this right here is 4 times, and that's a negative x cubed. And then 4 times, and remember that's understood to be a negative 1, so 4 times a negative 1 is negative 4, so that's negative 4x cubed. That's what you're going to see. So you can write either this, or you can say y equals negative 4x cubed. They mean the same thing. Okay? They mean the same thing. And you may say, but I thought that if there's a negative out in front, that's a reflection about the x-axis. Good point, isn't it? That is true, isn't it? And let's think about this. All right, I want you to think about this. So let's look at the graph. I'm going to show you that. I'm going to show you this. That reflecting about the x-axis, and reflecting about the y-axis. Let's see what that does. All right, so reflecting about the x-axis and reflecting about the y-axis for x cubed. This is true only for x cubed. All right, x cubed because of the shape of it. Okay, so remember x cubed, what x cubed looks like. So we have 0, 0, 1, 1, and we have 2, 8. And then, so that part of the graph looks like this. Okay? And then we have -1, -1, and then -2, -8. And so that part looks like this. So this is x cubed. Okay? All right. So if I were to reflect x cubed about the y-axis, if I were to reflect it about the y-axis, I want you to see what we get. So we get 0, 0. 1, 1 becomes -1, 1. And then 2, 8 becomes -2, 8. Okay? So I get this. And then over here, -1, -1 becomes 1, -1. And then -2, -8 becomes 2, -8. And so I get this. Okay? So do y'all agree? Do y'all agree that this right here, what I just did was I reflected about the y-axis, right? So that means that my transformation would be this. Y'all agree? Okay. But I want you to think about this. Isn't this right here, if I take this and reflect it about the x-axis, don't I get this? And if I reflect this about the x-axis, don't I get this? So if you reflect about the x-axis, doesn't it become this? It sure does. So what you need to what that tells us is this, that taking x cubed and reflecting about the y-axis is the same thing as taking x cubed and reflecting it about the x-axis. All right, those are the same thing. So that's why over here you're going to see that you can write it one of two different ways. All right. Okay. So that one was that one. So I'm hoping you understand that for x cubed, it's only true for x cubed, by the way, that the reflecting about the y-axis and reflecting about the x-axis produces the same end result. Okay. So that was number 9. Let's look at number 10. So number 10, we have this. So number 10, you're given this graph right here. And the direction says this, so you got to follow the directions very carefully. So the direction says, come up with an equation or formula for f of x. And f of x is, okay, I'm sorry, I'm reading it wrong. Okay, so the formula equation for f of x is given. And so f of x is x squared here. So that's your quadratic function. Okay? You want to find a formula or equation for g of x. So you just got to remember some things we've learned. So notice what transformation is occurring here. So I'm taking f of x, I'm doing what to it? So you're shifting it down, aren't you? So I'm shifting it down, and then I'm shifting it down how many units? 1, 2, 3, 4. All right, same amount, right? So there's no stretching, there's no shrinking, there's no reflection at all. All I'm doing is shifting it down 5 units. 4 units, excuse me, 4 units, and so that's all you do. So then you're going to say this. You're going to say g of x then. G of x, let me go ahead and do this here. So g of x then will be x squared minus 4. So x squared minus 4. So there's your answer. Okay, so that's number 10. Number 11 is this, though. Okay, now be careful with number 11. So you may say, oh, well, that's easy because that's a reflection about the x-axis. You got to be careful, though. So because look, if I reflect, if you're saying all it is just a reflection, that's not true. Because look, if I take the point 1, 1, reflect it about the x-axis, that's where it would be. But your graph doesn't go through that point. If I take the point 2, 2, reflect it about the x-axis, I get this, right? But the graph doesn't go through that point. So what that means is that not only is there reflection about the x-axis, but there is also a vertical stretch or shrink involved. There's also a vertical stretch or shrink. Okay? So we got to figure out what that is, that vertical stretch or shrink. Okay, so what I would do is this with this one. This is what I would do. What I would do with this is before a reflection occurred, let's move this thing back up. So we're going to take this and move it, and we're going to reflect it back up. Okay, so that means that at this point here, which is 1, -2, becomes 1, +2. So again, what I'm doing is I'm going to reflect this back up to help me determine what the um, factor is that this is changed by. So 1, -2 becomes 1, 2. Then we had another one that says 2, -4, so it'll become 2, 4. And over here, look at this. This is -1, -2 becomes -1, +2. And then -2, -4 becomes -2, +4. So what I'm trying to do is figure out what my factor is. Okay, so I'm going to go ahead and graph this. Okay, I'm graphing this. All right, so do you agree that this is my basic function, and so this is a stretching, right? A vertical stretching. Okay, so notice what we got to do is figure out, well, what is that factor right here? How did this increase by what factor? Okay, so notice that this distance is 1 and this distance is what? 2. This distance is 2 and this distance is what? 4. So let's think about this. What is this y value right here? That y value is 1. What's this y value right here? 2. Okay. What's this y value right here? That y value is 2. What's this y value right here? This y value is 4. So what do you think the vertical stretching factor is? The vertical stretching factor is 2. So I multiply this by 2, I get this. I multiply this y value by 2, I get this. Okay? So what we're doing here is this now. So my transformation, my first transformation was stretching by a factor of 2. So that was my first transformation. So this is right here. y1 equals 2 absolute value of x. Okay. Then I did the reflection, and when I did the reflection, I got what I want. So then this becomes g of x becomes -2 absolute value of x. So that's the way I would do that. So you're given your basic function and you're given your final. You weren't told anything about the other transformations. But obviously, you know there were 2 transformations that occurred, right? So there was a reflection and there's also a stretching. All right, so to figure out what that stretching is, I just went back and put this back up and figure out what my factor was. Okay? All right, so that was B. Now let's look at C. So C, you have this. You have so it says the formula equation for f of x is this. So here's the cube root of x right here. Okay? So this right here is the cube root, so that's equal to the cube root of x. So the cube root of x looks like this. So it kind of makes sense because if x is 1, the cube root of 1 is 1. If x is 8, the cube root of 8 is 2. And the cube root of -1 is -1, and the cube root of -8 is -2. So that's how you got this graph. But what did I do to this f of x? What did I do to get this one? What transformation do I need to do to get this graph? Well, if you look, all that's happening is just a vertical translation in it. That's just one transformation, and it's just that vertical translation. So I'm taking this graph and I'm shifting it up. How many units? 1, 2, 3, 4, 5. 5 units. So then you say g of x then is the cube root of x plus 5. There's your answer. Cube root of x plus 5. All right, so let's see. Okay, then D is this. So here's D. And so notice that that so f of x is your basic function, and that's your square function. That's x squared. Okay, and you want to come up with a formula for this one. You want to come up with what's the equation for this one. So you know that this is x squared. What you want to do is figure out what this is. Well, look at this. So notice if you think about this. So if I were to go to the right, okay, move this to the right and then move it down, when I get this right here, and there's no stretching or shrinking, because notice from here, this is 1, and the same spacing here. So you have the same spacing as the same shape. So all you did was just move it to the right and then down. Okay, so what that means then is that g of x will be, okay, if I move this to the right, I'm going to say x minus, and this was how many units? So 1, 2, 3, 4, 5, 6 units. So x minus 6 squared, and then I'm moving it down 1, 2, 3. So minus 3. So that's your answer there. So you move to the, so just look at your vertex, move to the right 6 units, and then down 3. So x minus 6 squared minus 3. So it's D. All right, now let's look at this one. So in A, you have this. So this says, the given figure shows a transformation of the absolute value of x. And then you want to write an equation for this transformed graph. All right, so what I would do is in this case, you're not given the basic graph like you were here. So you see the difference between this one and this one is that you were given the basic graph. Here, you're just told this. Here's my final graph, come up with it. That's what you're told. So, but then didn't having this help you? It did help, right? Because you could visually see what was happening. I go to the right, I go down. So what you may want to do is actually graph the absolute value of x. So let's graph it. So 0, 0, 1, 1, 2, 2, 3, 3, and so on, right? So there, this is right here, the absolute value of x. Okay? All right, so there's the absolute value of x. So what do you think's happening here? So it looks like see the vertex? It looks like at some point I'm shifting it up, right? And then what else is happening? And then I'm reflecting it. Okay? So let's think about this though. Okay, so remember though our order says that I got to do the vertical translation last. So I'm gonna do the reflection first. So let's go ahead and reflect this, see what happens. So to reflect this, I get 0, 0, negative 1, negative 1, 1, negative 1. I'm reflecting about the x-axis. And so I get this, right? I get this. Then I'm going to shift it up 6 units. And the question is, do I get the same graph? So if I shift this up 5 units and shift this up 5 units, 1, 2, 3, 4, is that the same thing? No, it's not. So that means then is that I have a stretching occurring or a shrinking. So I got to figure out what that is. So this one's a little bit more complicated to figure out. So you got to determine, well, what is it? Okay? So here's what I would do. So what I would do is I would go ahead and redraw this in another grid, because it is difficult. It is difficult to determine the way it's situated, to determine what my factor is, what my stretching factor is. So what I'm saying is this: I would go ahead and take this black graph and orient it to where it was in the same pointing up like my basic graph is. And the way I'm going to do this is I'm going to make this vertex come back to here, and then I'm going to reflect it back across the x-axis. All right, so what that means is this. I'm going to shift this down. I'm going to shift this down 5 units. So I'm going to move every point here down 5 units, and then I'm going to reflect. Move every point down 5 units, then reflect, okay? All right, so listen carefully. So 1, 2, 3, 4, 5. So that's going to be here. Okay, let's look at this point. See the point 1, 3? The point 1, 3, move it down 5 units. 1, 2, 3, 4, 5. So I'm going to plot the point negative 1, 1, negative 2, but then we reflect it back, so it becomes 1, 2. So 1, 2. And really that's all I need. I just need 1 point here. So I'm going to go ahead and graph this. Looks something like this. Okay. Then on this side I'm going to do the same thing. So I'm going to move this point. See this point here, right here? That's negative 1, 3. I'm going to move it down 5 units because that's what's happening. I'm moving this down 5 units back to the vertex, back to the origin. So 1, 2, 3, 4, 5, and then we reflect it back across the x-axis. So the point negative 1, negative 2 becomes negative 1, positive 2. All right, and so I get this. And I think now you might, and let's go back. So this is my, so this right here is this just reflected back across the x-axis, and this is the square root right here. So I think you can now tell me what my scale factor is here. So this is absolute value of x, then absolute value of x, then y1 is going to be what? So remember, you're stretching. So what do I need to multiply 1 by to get 2? What do we need to multiply 2 by to get to get 4? Okay, so 2, right? So my scale factor is 2. So this is 2 absolute value of x. So that is the scale factor. So doing it this way, it's easy to determine your scale factor than where one's pointing up, the other one's pointing down. So it's a little bit difficult. So at least you know your scale factor. All right. So I know my scale factor is 2. All right. So let's talk about this now. So I want to graph this. So the first thing you did was you graphed the absolute value of x. Okay. And then you multiplied by 2 to shrink it. To stretch it, to make it look skinny. Okay. Then you reflect it because the graph I want is upside down. Then you reflect it, and then you're moving it up 5 units. So my function is going to look like this. So you're going to say, and they want you to, okay, they didn't tell you what function notation to use, so we're just going to say f of x. So f of x, my answer will be, for the black graph, my answer will be, I'm taking the absolute value of x, the absolute value of x, okay, I am multiplying it by 2, then I'm reflecting it, and then I'm shifting it up 5 units. So there's your answer. So that one was a hard one as well. So you had to, what we did was we had to redraw it to orient it in the same direction, having the same vertex. So if you can get to have that same vertex and then the same direction, pointing in the same direction, it is so much easier to determine your stretching factor or your shrinking factor. Okay? All right, and then finally letter B. So letter B is going to be that same idea. So what I'm going to do is you have this the absolute value function, okay? And here's what I want you to do. So we're going to draw the absolute value function just like we did here. So I'm going to go ahead and draw it. So 1, just like this, and then here, okay? And we may need to go to another grid if it gets a little too messy. What I want you to know though, is this shape the same as this shape? It's not, because this one looks much skinnier than that one, right? So here you do have a scaling factor as well. Okay, so let's talk about how to find it. What I would do is I would move this back to where it has that same vertex. Okay. All right. So to do that, this is what we're doing. So I'm going to go to the right and then up. Okay, to the right and then up. All right. So just follow me along. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Then take this point here. 1, 2, 3, 4. 1, 2, 3, 4, 5. Then take this point here. 1, 2, 3, 4, and then go up 5. 1, 2, 3, 4, 5. And now you have now, watch, you have this graph. You just moved it back to where the vertices oriented. So now you have this. So I'm going to draw this. Okay, that's what I have. Okay, now I'm going to use this now to help me with that scale factor. So you see what I did? So to get that scale factor, I had to reorient the red graph and the black graph so that way they had the same vertex pointing in the same direction. And then right away, I can figure out my factor. Same thing here. I reoriented my vertex to get to the same spot. So I had to go to the right and then up. So right, so everything here moved the same direction. Right, up, okay? Now you know what the scale factor is. Look, so it's a vertical stretch. So my y value is 1. What's this y value? 3. My y value is 2. What is this y value? I should do this. I'm sorry. Should do this. Okay. What's this y value? 6. So what do you think the scale factor is? What do you think your stretching factor is? Your stretching factor is 3. That's what it is. So if this is the absolute value of x right here, then this is going to be 3 absolute value of x. Okay? All right, so now you know what to do. Okay, so this is going to be our answer. So we're trying to get the black graph, right? So I'm going to take this now, right here. So I found my stretching factor. I'm going to take this now, and I'm going to shift it. So remember, you always do the horizontal before you do the vertical. So I'm going to shift it horizontally. So horizontally, use your vertex. 1, 2, 3, 4. So horizontally to the left 4 units, right? And then down 1, 2, 3, 4, 5. So my answer is going to be g of x will be 3 times. All right, now remember I'm taking care of the horizontal translation. So I went to the left 4, right? I went to the left 4 units, so that means x plus 4. And then I went down 5, so that means minus 5. So there's your answer. Okay, so these two were difficult, and you had to rearrange those so that way it had the same orientation at the origin, where they had the same vertex. Okay. All right, so that is our lesson on this. So you may want to go back and review these problems, but there's enough there to get you to understand this whole idea of transformations much better. So that's the end of this lesson.